Welcome to Unit 5, Networking in Server Environments. Now, I'm assuming that before this class you've had extensive experience with networking, either through another college class or hands-on experience. You should be familiar with the 7-layer OSI model. If you are not, there are several videos on my YouTube channel under the playlist CS318, Intro to Networking and Security, that you can use to get yourself up to speed. Armed with your knowledge of networking in a desktop sense, let's start looking at some of the nuances of server networking as opposed to desktop networking. At layer 1, which is our physical network, there's a couple of subtle differences. We've already mentioned in the hardware section, for example, that servers often have more than one physical Ethernet port. This is important because it means we have a larger number of network cables going to each server. And if you can imagine a 42U rack loaded with 1U servers that each have 4 networking ports per device, we're going to have a bundle of over 100 cables going to that networking rack. And as you know, electrical Ethernet has significant issues with electrical interference, especially when we start to bundle cables more than 100 thick. As such, we will often use fiber to get networking to a rack, and then from switches within that rack, expand using electrical Ethernet to each of those individual servers, trying to reduce the length and number of Ethernet cables that are bundled together. Also, because of the number of cables, number of servers in that rack, we definitely need to make sure that we route cables properly and keep them organized so that we can maintain them in the future. Proper labeling will also be critical. Proper documentation of what's plugged in where will be critical to making sure that we can maintain those servers and keep the network running, or make changes as needed. Now, on the topic of network interface cards, which is really a layer 2 technology, network interface cards inside of servers may have additional features. PXE, or PXE, the pre-execution environment, is a substantially useful feature on servers. Now, it's an annoyance in the desktop world because it essentially is an environment that allows our computer to boot off of a network resource. And in the desktop world, we rarely want that, unless we're using the network to distribute system images to a set of computers. In the server world, however, realize that PXE can be particularly useful if we're trying to boot our computer off of network resources, much as we would with a network-attached storage or iSCSI system. Also realize that because we have multiple NICs inside of a server, the concepts of NIC teaming or link aggregation become significantly more advantageous. Now, if you don't remember those from your networking class, we can essentially use multiple network ports, kind of like we use RAID or hard drives in RAID. We can combine network ports on a server and multiply the amount of bandwidth between a server and a switch. Similarly, we can use load balancing or redundancy by using multiple network adapters connected between a switch and a server in order to prevent loss of connectivity if a single line goes down or a single network interface dies. Now let's consider server networking from the layer 3 perspective, or the IP address layer. In the desktop world, our computers typically have one IP address, typically only one port. But in the server world, where we have multiple ports, our servers may have multiple IP addresses. In fact, they may have multiple IP addresses per port. Now, we can do that in the desktop world, but we rarely do. In the server world, it's going to become significantly more commonplace. Now, usually these IP addresses are going to be on different logical networks in order to allow connectivity for that server on different separate networks while maintaining separation in those networks. And when it comes to the idea of separate logical networks, we need to start talking about NAT and PAT, network address translation and port address translation. Now remember, NAT and PAT are used most often in our desktop world in order to translate between our logical network or our local area network and the wide area network, or the internet. Our router will typically do either NAT or, more commonly, PAT, port address translation, in order to put that computer out on the internet to access resources like websites and email. In the server world, we're also going to see NAT and PAT, including in a router connecting servers to the outside world. But realize that it may become more important to favor network address translation, NAT, over port address translation. With NAT, network address translation, all of the ports are available on both sides. In other words, we take one internal IP address and map it to one external IP address. So all of the ports, all 65,536 of the ports on the outside, are mapped to the internal ports. If we have a web server, a mail server, an Active Directory server, or any type of server where we have multiple ports being used, we need to use that network address translation so that those ports are available on the outside network as well as on the inside network. And network address translation will give us that one-to-one. Port address translation essentially gives us one external port for that device, which won't necessarily give us the ports that we need in order to offer those services through a router or through a firewall. Now, one solution to that is port forwarding, where we have one external IP address and we have a series of ports on that external IP address which are mapped to specific ports inside. Since that external IP address still has 65,536 ports at its disposal, we could map 5 to 10 per internal IP address and get away with just having one external IP address for a series of servers inside. But the preference in this case is going to be that network address translation. This is where large network blocks become very important to the server world, even though they're expensive. When it comes to network equipment, both inside the server and outside the server, it's very important that we stick with name brand equipment. Cisco, Juniper, Intel, Broadcom, HP. The reason for this is that these network components are actually designed to withstand the duty load of a server. I'll give you an example. This is an 8-port gigabit switch designed for desktop use, and it has 8 1 gigabit per second ports on the back. However, based on its size and its age, I know for a fact that this device could not handle a full 1 gigabit per second on all of the ports at the same time. It's essentially designed to have one full-speed conversation while maintaining minimal connection on the other devices. Another reason that I know this is because when you look at enterprise-level switches, they're significantly larger. They have a lot more hardware in them to ensure that every single port can reach its full potential at all times. In other words, the max throughput of this device is about 1 gigabit per second. Maybe if we're generous, 1.5 gigabits per second. Where the max throughput of an enterprise switch that was also an 8-port would be at least 8 gigabit per second, because it's going to offer full bandwidth on every single one of those ports. Similarly, internal network cards, as we mentioned in the hardware version, desktop adapters are going to rely on the CPU and system resources in order to process network traffic, where an enterprise class network card, especially one from these brand name suppliers, is going to have the proper technology, the proper CPU, memory, microcontrollers built into it to handle all of the network traffic on the card and not burden the CPU at all.